Machine Learning Studio.
Good afternoon, everybody. My name's Todd Robinson. I'm a data analytics architect for Covenant Technology Partners. I'm going to admit somebody. I hope everybody can see my screen. Ollie, tell me if you can't.
You're all good.
Excellent. Okay, today we're going to talk about machine learning as part of a modern data warehouse series of webinars. It's a little bit out of order, but that's okay. My enthusiasm is behind Machine Learning Studio, so that's what we're going to talk about. And we're not going to talk about how to do how to build an experiment per se. Rather, we're going to concentrate on how to operationalize it and some of the challenges and some of the techniques around that. Here's the agenda, and we're going to, I'm going to talk about that in the framework or using a use case of customer churn. And what that means is it's important to people to retain their customers. And with Machine Learning Studio, you can define an experiment that will take your existing customer base and predict or provide some information based on past history about whether or not you think that customer might be at risk or at danger of leaving. And we're going to do this with the use case of customer churn. And the situation is if we're going to imagine that there's a business application around a call center and a customer calls in, and what's going to happen is within that customer call center application, an API call is going to be made to Machine Learning Studio and take that specific customer's information and predict whether or not this customer is at risk. So we're going to take a look at Machine Learning Studio, go over at kind of a high level how to get to the point where you can make that API call and what's involved in at a high level the specific model, as specifically exploring the data, feature selection, model construction, and then the operationalization of that model. And then we'll talk just a tiny bit about modern data warehouse, and then I'll take some questions. So so here's our use case. A customer calls into a call center, and the call center person enters the relevant identifying information and gets a return of that particular customer's data, which I'm showing at the bottom of the screen there. These are the attributes of that customer that are going to go into the model to try to predict if this customer is unhappy or if at risk of leaving. All right. Let's begin with at a high level what goes into model building, or what's being called here the data science lifecycle. And where it really begins is with a certain business understanding. In other words, knowing what kinds of things you want data science or predictive analytics or data analytics to answer. You just, it's not really helpful just to try it. It's much better if you have a question that you want answered. And in our case today, the question we're asking is, will this customer leave? And once you have that basic business question or business understanding, then you go about looking at what kind of data you have that might support a predictive analytics application. And then you would take that data, build, train, and evaluate a model, and then you would deploy it so that you can use it. And the way to do that is with this tool or this Azure service called Machine Learning Studio. So let's take a quick look at what that API call would look like. If I can switch my screen here, I'm sorry, I don't think I can do that. Strange, can't do that in Teams. Let's take a look at Machine Learning Studio instead. What I was hoping to show you was how to do an API call within Excel. Okay, this is ML Studio, and everything begins with a training experiment, which I've already created here. There are different kinds of trained models that you can build with Machine Learning Studio to do different things, to satisfy different use cases. There's at a high level, there's anomaly detection, there's classification, there's clustering, regression, and you can even do some with some custom scripting, either R or Panda. You can write scripts and build your models with those languages. Okay. What I'm doing now is, and I apologize for this, but I must have changed the model somehow, and now I've got to regenerate the web service, which we will let go for now, and I will go back to the training experiment. All right, so what we're looking at here is how you would explore data, you would train a model. Let me get rid of this. And then you would operationalize it here at the bottom. The first thing that happens when you build a model is you have to get data. And this is a module called the import data, and you can import it in various ways. But for this particular experiment, I'm importing it through a blob storage out in Azure Blob Storage. And if I right click on that output port, I can go to visualize, and I can visualize the data that I'm bringing in for this experiment. And one of the nice things here is it gives you a way or a method to explore the data in a single place, and it's very compact. Here it is. It tells me the number of rows in this particular data set, the number of columns. And right here is a really nice feature where it gives me a histogram of each of the particular columns of the data, the attributes. And one thing I wanted to show here, there are 21 columns of general customer type information, but one thing I wanted to stress is way here towards the end, and that's total charges. I've got certain summary statistics on each of these columns, and the one I want to talk about, they're all pretty vanilla for this particular use case, except here, total charges, which turns out to be fairly correlated with what I'm trying to predict, which is this label column here called churn. But the thing about total charges, and that kind of makes common sense, is that the more you charge, the less happy people will be, or the closer they might get to being unhappy. In this particular column, I note that there are some missing values. And what that means is in 11 of the 7,000 rows, there is no total charge. So for whatever reason from the source system, the total charges was not recorded. So why is that important? Well, it's important in terms of deploying this to the web, because one thing I'm doing in preparing this data is I'm using a module called clean missing data. And what I'm doing with those specific 11 rows is I'm taking the mean of all the other ones and I'm putting it into that missing value. And so the question is, well, okay, that's a fairly common technique for imputing data, but it's a problem when you call this model with an API call, because at that point it could be one row or it could be a few rows, but the point is you're not going to know the mean. So one of the things that happens when you deploy a model is it takes the values from modules that cannot be calculated via an API call when you're training the model, and it creates transforms for those. So the transform for that particular one is over here, is right here. And what it does is it stores that mean that you used from your training, and it will apply it on a row by row level should a single row come into an API call that doesn't have total charges. And there's another module that does the exact same thing, and that's called normalized data. Normalized data takes columns, in this case numeric columns, and what it does is it scales those that column with a technique here called the z-score. So it takes each individual value in a particular column, and it calculates the z-score for that value and uses that instead. And what that means is it takes the value, it subtracts off the mean of the entire set, and then it divides that by the standard deviation to get a z-score. And that's not something you'd have when you're doing a predictive, when you're doing an API call either. So it would take that z-score and save that off as a transformation when you build your when you deploy or you build your predictive experiment as an API call. Okay. Okay, so that's two things I'm using to prepare the data. I clean missing data and I normalize data. And the only other thing I wanted to show you about that, or two things really, was I'm going to go back and show the visualize here. Here are all the raw columns from the data set. There's 21 columns here. And what I do is I don't want all 21. I just want the ones that do two things for us. Number one, and probably most importantly, they contribute to the prediction. In other words, I've done the work to decide that these 12 or 11 columns are the ones that most determine churn, or in other words, they're the ones that are most correlated with churn. And the other reason I only use these is I'm kind of simulating that these are the ones that are easily available to the business when the call center app is invoked. And so I apply this module of limiting the data from 21 columns down to 12. And if we come over here, one of the things that happens when you set up a web service is it's going to attach a web service input. And it's going to attach it up here right next to the import data from the training model. And it's going to turn this off, and it's going to use this as part of the API call. That's going to be the header information or the input to the API call. And if we go down to the bottom, here is the output. And all that is automatically generated when you generate your web service. Now, there's one other thing I wanted to point out about this training experiment, and that is I've included way down here at the bottom an export data. And what I do is I export this data. We can visualize that output port. This is all of the metrics, or the metrics for the model that determine if it's a good model. And in this case, the metric that I'm concerned with most is accuracy. So this is saying that this model is 80% accurate. If I come up here and I look at this output port from the evaluate model and visualize that, for this particular type of model, which is a two-class logistic regression, I can see that what I get is a ROC curve, which if you're familiar with two-class classification models, that's one way of evaluating the model. And if I come down here, I have certain measurements of that evaluation, accuracy being one. But I also have precision and recall, which are also important, or important to me for this particular case. And one thing I do with those measures is I export them to a database so that I can, so what this enables me to do is to track the model's health, if you will, over time. So one thing I've done with this training experiment is I've scheduled it to run once a week. So when it's deployed to production, once a week, it will retrain itself and take the information from that training with no other changes, and it will save that off to a database where I can then apply a Power BI report, in this particular case, to do some trending, to see if the data, or I'm sorry, to see if the model stays accurate, which is important. And one thing you would assume, or you'd hope, or hypothetically speaking, is that the model as defined, if it stays static, that it would cease to be accurate over time as people call in and actions are taken with the customers, that they become, you get less churn. So in other words, the reasons for building the model in the first place with the values or with the attributes that were built are not so prevalent, because the actions you're taking are of value and customers are less likely to churn. All right. What we're looking at here is the actual, this is how you would go about building your API call. This is the web service for that training model that I just built. Now, there's two different API calls out of the box with Machine Learning Studio. One is what we've been talking about to this point, and that's request response, which is a single row or a few rows even that are sent to the model and bring back information about churn. The other way, you can do a batch execution, which you would send the API a file. It can be a blob, it can be a flat file, it doesn't matter. But it will figure out it will apply each one to the model one at a time and figure out the churn characteristics, or the label, what we're trying to predict. So one of the neat features about this is that out of the box, it provides everything you need to do an API call. And here it is, the 11 attributes that need to be sent in. And here is what you will get out when you do this API call. You'll get a string, which is a simple yes/no indicator of will this churn or will it not churn, and a probability. So if it says yes, it will churn, or no, it won't, it will also say, okay, the model says that there's a 50% chance of churning, or 80% chance that it won't churn. It's a very stable customer. Okay. Oh, and going further down here. If I look at the single request response, here is the actual post API request, and it also tells you the sample request, or shows you the sample request. And what's really cool about this is that if I go way down here, it'll also give me the representative sample code in C#, Python, or even R, which is very nice. For me, I use R. That this shows you for this given model, this is the exact code that you need to generate an API call to the model using R. Okay. Okay, now what I'm showing right now is an example of what that call looks like. And I'm using Excel to do that. So here we have a representative row of data for this customer and the attributes of that customer. And what we're going to do is send that to, well, I'll get rid of this. What we'll do is we'll send that to, we'll make the API call with Excel, and we'll get back the indicator of, yes, we kind of think, given this data, that this person will churn, and the probability of churning is 58%. Okay, that's okay. And one thing I wanted to show is tenure, as it turns out, and it's kind of out of scope, but tenure and total charges are the two most correlated attributes of this model. So if we assume that this has been a customer for 8 months, is what the tenure means, and that's not a long time. But if I change that to say, let's say that he's been a customer for 5 years or 60 months, and rerun the prediction, then we think he definitely will not churn, and he has a very low probability, 8% chance of churning. So what this means is you can target based on these particular attributes and how they change over time for your customer base based on the model telling you churn this of the particular customer. So that's one way to do the API call. Another way is via Power BI. Now there's quite a bit going on with this particular screen dashboard. This is just a dump of the table I was telling you about that I export every time the model is run. I export the metrics for that training, and that's just to show that. But the important thing is when this dashboard is run, I do a API call via the R code that I showed from the web service to see the top 50 customers that might be in danger of churning. And that would allow you not to wait on, say, the call center or the customer calling in and having an issue or a problem, but this would be proactive in showing you the top 50 customers that are at risk, that have the highest churn probability. And so you can be proactive, and you could give these maybe, I don't know, give them a call or something like that, or proactively adjust for these customers. And then the thing I like about this particular dashboard is this here. And what this is showing is the accuracy of the model over time, the training of the model. And that is back here in October, when I originally built this, I tried many different things, and as you can see, the accuracy is all over the place. But then I zeroed in on logistic regression at 80%, and I was fairly happy with that, so I kept it. And as you can see, it stayed fairly accurate until I artificially changed it to reduce the accuracy so that it would look good on this graph. And what this is demonstrating, that over time, if the model degrades, you could take a look at this, and once it drops below some threshold, like 80% or getting close to 80%, it might be time to go in and retrain the model in some different way. Okay. Okay, back to this. So I really just touched on training experiments, setting up the web service, and taking a look at the predictive experiment and deploying it as an API call. So there's another aspect of operationalization besides how the business is going to use it, how you would embed that as a web service into a business process. And I touched upon it a little bit in that you'd want to not just create a trained model, throw it out there as an API call, and just use it forever. Because as I said, you would expect that to its performance to degrade over time as the using the model itself affects the results of the model. But there's another aspect of it which has to do with how do you fit that model into your other IT, change control, lifecycle management. One way of doing that is within ML Studio itself. And that is, every time that this model is run or trained, it keeps track of it. So it's not your standard change control, but it is a method of tracking changes over time. You can run any single one of these, or take a look at them, or see how they worked in the past here in the run history for that particular one. Now, another method you could do is you could store the actual code in something like in some version control tool like TFS, Git, or Subversion, something along those lines. And the way you would do that is you would have to save off the model itself, which is not the easiest thing in the world to do. But basically, you would attach a output to the model itself, and you would save that off as code, and then you could put that in your tool, TFS, Git, whatever. So that's to fit it into your standard IT processes that you might have. Okay. So how does this fit into a modern data warehouse framework? Well, we saw how you could use the API calls via R scripting in Power BI, and we saw the model itself with Azure ML Studio, briefly how to build that, and some of the challenges with making that a predictive a web service. But also, I'd like to stress that by saving off each run of the model to, well, you could do it to blob storage, but in my case, I'm saving that off to Azure, an Azure database, SQL database. That gives you control or some visibility into how your model is performing over time, which is fairly useful. Another thing you could do is to use Azure Data Factory to schedule or to make those API calls. That is another way you can do that. And how that works is there's an activity in Azure Data Factory specifically for trained models, and you can either do it in either one of the two ways that I talked about, with single row request response, or which is more likely, you would do it in some kind of batch mode with the batch execution service. And so what would happen with that is you would create a ML model, and you would put it into an Azure Data Factory pipeline as an activity. And one of the pre-activities that you would do is save off customers that you want to run through your experiment, your web service, and use Azure Data Factory for that. And so that is a method for bringing in or bringing in an experiment in the modern data warehouse framework. So really didn't spend a lot of time on it, and I apologize for that, about how to actually define or use ML Studio, because I really didn't want to get dragged down into the complexities of data exploration, feature selection, feature engineering, and the mechanics or the nuts and bolts of actually creating a model. That'll be another webinar, and that's really where the meat and potatoes is. That's very interesting. But the point is that you should keep your models simple. They should satisfy a business question and no more. uh, it's much better to have a simple model, or it's not much better, but it's a little bit better to have a simple model that satisfies or answers a question adequately, as opposed to having a very complex model that really drills into the data and squeezes every last ounce of predictive power out of it. It's better to keep it simple and make it very explainable. And as I said, it's to me, it's really a nice feature to save off the model performance and to keep looking at it over time. Because what you would hope would happen is that you build many models. So you get to the point where you can't go in and retrain models on a daily, weekly, monthly basis. You have to have some kind of method or strategy for the model to be to run itself, really, to be on automatic, and so that you can just as we saw in Power BI with that trending report, to just to be able to look at it and say, oh, it appears to be performing adequately. And if you visualize it, it'd be nice if you had like a dozen models that do different things, and you can just quickly glance at them and say, okay, they're doing what they're supposed to be doing, and you can go on and do something else. And another thing that I touched on just a tiny bit was to optimize data usage. And what that means is it needs to be important to the business. It can't be very obscure or esoteric data. It has to be data that makes sense, and it's to the very commonsensical data to the business that is easily obtainable. And the story, or the rationale there is back to when Kaggle had the competition for Netflix, and the model that won was very, very powerful, but it cost too much, and the construction of it was not worth productionalizing. So I believe that Netflix never did put that particular winner into production. And of course, this is just code like anything else. And so it's very important to test as much as you can, or the way I would put it, all the testing that fits, and you have time to do. It never hurts to test more. And then also you need to create a model or a machine learning process that is easily explainable. At least in this day and age, it needs to be explainable to people who maybe aren't that technical. That is all I've got. Can I answer any questions that anybody might have? I know I sped through that. So are there any questions? Hello?
I don't think we have any questions. So thank you so much, Todd, for presenting on this, and we look forward to the next webinar in the series.
Okay, well, thank you very much.
Have a great day, everyone. Thank you.
You too.